So find a sinusoidal function that matches the graph given. If needed, you can type pi, the symbol, in. You should totally use pi, the symbol. You can just write the letters pi, or you can use the entry box to click on the pi. Otherwise, use at least 3 decimal places, which is ridiculous. You should use the symbol pi. So I took a screenshot. So here's a picture of that graph so that we can write on it. So I'm going to put some guidelines on here. I always do that as my first step. So I can see the maximum is up here at 3. I can see the minimum is down here at -3. And in this case, that makes it pretty easy to find where the midline would be. The midline is going to be halfway between the maximum and the minimum. In this case, right along the x-axis. That might not always be true, but from this, I can tell a couple of things. First of all, the vertical shift. The vertical shift is the location of the midline, and in this case, 0. In the equation, I'm going to call that d. So d, or the vertical shift, is 0 since it goes across the x-axis. The other thing I can tell is the amplitude. So measured from the midline up to the maximum, or from the midline down to the minimum, you're going to get the same measurement. That is the amplitude. And in this case, it's 3. Next, I'm going to want to find the period. So you can find the period in lots of ways. We need one complete cycle of the wave. Sometimes people like to go from maximum to maximum, which makes a ton of sense. In this case, however, those maximums appear to occur like halfway between my graph paper lines, and so that makes it kind of difficult to determine exactly what the period is. So another approach is I can do trace out one complete cycle of the wave. So again, starting from the maximum, where cosine would start, is going to be problematic because I can't tell exactly where the maximum point is. It looks like it's right in between those graph paper lines. But if I did sine, then I'd want to start from the midpoint right here. One complete cycle is going to end right there. And now I can see the length of the period starting from -14 until 0 gives me a period of 14. So now a lot of times we see graphs that have a period given in terms of pi. That happens. This one is not given in terms of pi. So if the period is 14, fine, the period is 14. I'm not going to drop that 14 straight into my equation regardless. So my next step is I need to find the k value that I'm going to put into the equation. K is always, 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 always found by 2 pi divided by the period, which in this case is 14. So when I reduce that fraction, 2 pi over 14, I'm going to get pi over 7. That is my k value. That goes into the equation. Lastly, I am going to need to find the phase shift. So phase shift, or horizontal shift, we can call it horizontal translation, is going to be the part of the equation which I call C. And so that is the sideways shifting or sideways translation that is necessary to get to the starting point. So I'm going to go with the period I just traced out in the graph. I highlighted that in blue. The starting point was over here at -14. So that means my phase shift is left 14 spaces. And in the equation, the phase shift is always going to have the opposite sign. So even though that's happening at -14 on the graph, the phase shift is going to be the opposite sign, plus 14. Okay, so I have identified all of the pieces that I need to write an equation. I didn't write this down, but lastly, I traced out sine So I have a choice of doing either sine or cosine. Either one will work and be correct. But in this case, since the cosine would start at a maximum and I couldn't tell exactly the value that the maximum was going to be at, I could do some thinking and figure it out based on the other points that I can see on the graph. It would be exactly halfway between, depending on which maximum I'm looking at. That maximum right there in green is going to happen at 3.5. So I could use that and write a cosine equation. Or I could start from this blue dot right here, which will be at negative 10.5, and I could write a cosine equation with that as my phase shift as well. But I'm going to start off by using sine, because that's the shape that I traced out there on the graph, starting from negative 14. So here's what the equation goes like. Y equals, amplitude goes first, and that was 3. I chose to use sine for this equation, so I'm going to put that next. And then I need a couple of sets of parentheses, so I'm going to start with a square set. And first thing that goes in the parentheses is my k value, pi over 7. Then I'm going to start another set of parentheses. My variable, it goes inside this next set of parentheses. And the original equation, it gave me function notation f of x. I got to pay attention. If it's telling me the function notation f of x, I have to use x as my variable. There's no other option here. You know, if I was writing it on paper, I could use whatever variable I want, but not here. So I have to use x. Next comes phase shift. We said that's going to be plus 14. Close both sets of parentheses. And lastly, I need to get my vertical shift. I mean, it's 0, so I guess you could be fine without writing it, but just for the sake of clarity, I'm going to show you, here's where my vertical shift is at. Okay, let's look at final answer. There's some other options we could do instead of that. I could have taken this blue trace. Let's see if I can get rid of this other piece of highlighting. Right there. Okay, so starting from where the blue highlighter is, right there at the origin, I could totally do that. It would actually be a lot easier. I wouldn't need a phase shift at all. You can't actually see the whole wave pattern that I traced out as it's off the edge of the graph, which is fine. It's a sinusoidal graph. It's going to continue doing the same thing over and over and over and over and over and over and again. Okay, so no phase shift would be necessary. I could write a different equation. So different possibility, still using sine, amplitude stays 3, the function transformation, or the period transformation k, still pi over 7, but I can get rid of this phase shift. In this case, I actually don't need this inner set of parentheses, and actually in neither case do I really need to have my vertical shift, but I'll just leave it there for illustration purposes so you can see that is where the vertical shift would go if one were needed. Okay. Another possible option, which I discussed earlier, is we could do a cosine graph. Cosine would start at the maximum, so that would look like this, starting from that blue dot, which is at negative 10.5. So a phase shift to the left, 10.5 spaces. I'm going to write using cosine this time, and my phase shift is going to be plus 10.5. And that phase shift is the only thing that's going to change in addition to using cosine instead of sine. So this would look like cosine and plus 10.5. And this is another possible option. It gives you the same graph. The equations look different. I mean, they are written differently. Each of those equations is going to produce the exact same graph. There is literally no difference in the end product of what that graph would be. One final option, we could do a phase shift using cosine. We could do a phase shift to the other side of to the right by 3.5 and start here at this green dot. So that is going to look like a phase shift minus 3.5 instead. Minus 3.5 right there. And then there are some other possibilities. If you wanted to include a negative amplitude, you could do that. I don't think I'm going to write those all out right now. But if I was going to do a sine graph with a negative amplitude, I could start at the midline and go down first. So that would be one wave cycle. So I'd have a phase shift left 7 spaces, and I would need to change my amplitude to be -3. Similarly, we could do cosine with a negative amplitude. So cosine with a negative amplitude is going to start at the minimum. So like right here, I'm going to choose that phase shift because that way I can draw the whole pattern from minimum all the way up and then return to the next minimum. So that'd be a phase shift to the left of 17.5, or in the equation I'd write plus 17.5. And in this case, I would need to write my amplitude of -3 cosine. So there's a lot of possibilities out there, and this is the process I would go through to come up with an equation. Any of these is going to work. WAMAP is got no problem with you doing sine or cosine either way, and so good luck.